Okay, I'm going to explain this worksheet and the one that follows it. What we have here is a model of a stochastic process. The model is given by this transition matrix. There are two possible states, up and down, and this represents the probability of transitioning when you're up into either up or down. Here's the probabilities of transitioning to up or down when you're in the down state, and here is the initial state. So you set those. You can run the simulation. The simulation has already been run once. I'm going to reset now so you can see what happens when it's reset. So it starts it back at 0. I'm not going to actually run the simulation because it takes a while and takes some processing, but I do want to show you how you can change the model. So right now we have the correlation parameter at minus 0.2, and let's make it at 0. And then we can see what the correlation parameter does. When it's at 0, the probability law in both rows is the same. That's what we mean by independence, that the probability law in both rows is the same. The drift parameter is 0.2, meaning there's more of a likelihood to go up than there is to go down. So the path will tend to go up here. It doesn't always go up, but there's a tendency to go up. If I made the drift parameter 0, let's get it 0, then there's no tendency for it to go up or go down. It'll bounce around a little bit because it has to move, but it has no tendency to go up or go down. And if you make the drift parameter negative, then there's a tendency for it to go down. Let's put the drift parameter back at 0 and see what the correlation parameter does. The correlation parameter, when you make it positive, puts more weight on this diagonal. So if you're in up, it makes it more likely to stay in up. If you're in down, it makes it more likely to stay in down. That would increase the likelihood of a streak, incidentally. And if you make the correlation parameter negative, then there's more weight on this diagonal, which means there's more of a chance to change states, and that would shorten streaks. Okay, so we have a sense of this, and I encourage you to run sims trying to use this. There are 1,000 periods that are plotted. It takes 4 or 5 minutes to run this thing, so it's not a trivial matter. After you've run it, you can go to this sheet, and what you do is you take the results from your simulation and paste them into column A, and then it will count the maximum length of streaks. And if you stare down here, it will actually give you a sense of, are you having lots of streaks that are a little bit shorter than the maximum one, or are streaks fairly infrequent? So you can get some eyeball looking down the columns as well, but you can get immediate results about the longest streak with just looking at the top here. And then what's plotted here is the parameters of the model. So the model is a big influence on the maximum length streak. This was a 50-50 independent model starting in down, but it really doesn't matter when it's 50-50. And the maximum length streak is 10, which is just about what we would expect. So there you go.